And this problem is a continuation of house robber that we have solved previously in previous video. So just to go over it one more time, um, we are given these houses which holds some type of amount of money, and then our goal is to return the highest, um, the maximum amount of money that the robber can rob. So there are some rules. So if it is robbing the first, it cannot rob its the second house because it is adjacent. If it's adjacent houses, when it's robber is robbing, that means automatically there are some security cameras that it automatically contact the police, so you cannot rob adjacent houses. And in this problem, there is also another rule. So these houses are in circles. So first house and the second house, they are neighbors to each other. So those are also adjacent. So first, let's just solve it in our previous problem that we solved the same way and without thinking of arranged in a circle. And later we will just add this logic. So the, the way we are going to add this logic is we are going to send two different arrays, because like we will be just sending array from 1 to 2 and 3 to 2. So this case, first house and last house, they're not going to be related to each other. And like in this example, we cannot, if we start from the first house, we cannot go to this adjacent house, and this last one also it's adjacent to the first one. So from first house, if robber robs, we get 2 amount, and from the second house also adjacent to 2, so we cannot go to anywhere, so 3. And then from the last one, it's just 2. So out of them, if robber chooses to rob the second one, it gets the highest money. So let's solve just like in the previous video. So this is a dynamic programming type of question, and what we are going to do is we will define our transition function. So our transition function, like we described in the last video, so this is an optimization problem, so we're trying to find the maximum. And when we are looking at the current amount of the house, we are also combining it with this second previous highest in our function. So our answer will be this one, which will be holding the highest amount of houses basically. So I negative 2, and we are comparing it to the previous one. So this is our transition function, and what we are going to do is just like solve it. Just actually, let's create a helper method. So this helper method will hold the nums, and this will be the one who will be solving it. And from here we'll be sending 2 different copies of nums, and then it will solve it in there. So let's take care of some base cases. If nums length equals to 0, which means there's no houses and there's no amount of money to rob. And second case, when nums length equals to 1, then there's only one house, and the amount that gets robbed, it's in our nums. And another case is when nums length is 2, That means we have two houses and we need to choose the larger one. So let's imagine that if we have two houses, and then it's like when robber is coming, it chooses the second one. So we are choosing from first house and second house. And like I was saying, from the main function, what our goal is, we can just, in order to take care of this train that we have, which is in circle, we just need to exclude them and send two different copies of nums. So for rob1, what we are going to do is we will call our helper robber method, and into here we will send uh, so we'll create a new nums array. We'll basically create a new array and send it, but we will be changing our arrays. So first time we will start from 0 and we will exclude the last one. So for the second one will be the same way. And then in this case we will start from the second house and exclude the first one. And once we get the maximum out of calculate for each these houses, and we will just return the maximum out of these results. Okay, now our private helper will be the similar that we have solved for house robber 1 problem. So let's just go over it one more time. Let's create our DP array, which will be the same size as the nums, and we will do some base cases when in DPs for first house, what will be the maximum amount? It will be the nums first one, because there's no other houses. For DPs 1, what will be the maximum amount? It will be the max between the first house and the second house. Now let's go over. We'll be starting with the second one because we took care up until here, and it will run until the nums length. And in here we'll just have our transition function here. We'll translate it into code. So DPI will be holding the maximum amount of money. So we are trying to update it. So we will be choosing between the current houses amount with we'll look up our TP, which was holding the highest amount. So since we cannot see the adjacent ones, we will go to the second previous one. We will compare it with the previous one. So whichever is larger, that's the one we will assign it to our DP. And in the end, our DP in DP's last index, it will hold the maximum amount. It will hold our answer. So let's run the code. Oops. Let's submit it. There we go. So Time complexity of this solution is O of n, where n is the length of nums array, and space complexity we are also using extra space, and it's also O of